Start recording. Okay. Okay. So actually, what we're going to do is we're going to be on page 103, please. Okay? Page 103. So most of the stuff on this page is stuff that you already know about. So we all know that group 1 has 1 valence electron, group 2 has 2 valence electrons, group 13 through 18 have 3 through 8 valence electrons. And the same is true for atoms in all of the other periods. And we know this already. They are always placed around an atom, top, right, bottom, left, or you can go right, left, top, bottom. That's what they suggest here. It doesn't matter as long as you don't pair them up until you have to. The one exception is helium. So we have one exception, and that is helium, which is He, and we draw the 2 dots together. It's not He with the dots separated. And we should already know that an atom likes to have how many electrons? 8. They like to have a complete octet of 8 electrons. This is called the octet rule. Notice that the noble gases already have 8 electrons, and so they are hardly ever involved in bonding. Now, what about our transition metals? There's really no electron dot notation for these, so you will never come across a transition metal. Okay? All right, and we already know what do we call the non-bonding electrons? What do we call those? Those are called electrons that don't bond. Those are called lone pairs. And how do we draw a lone pair? Either like this or like this. So oxygen has 2 lone pairs, chlorine has 3 lone pairs, and calcium has no lone pairs. So Lewis structures show us the 2-dimensional representation of how molecules look. Now, do you think molecules are really 2-dimensional? No, they're really 3-dimensional, and should you go on to study chemistry at university, you will learn what those shapes look like. I'll probably haul out some molecular models for you to take a look at, just so you can get an idea, but this year you won't be responsible for learning the shapes, okay? So there are some exceptions to the octet rule, and this is where we're getting into some new stuff for today. You already know one exception to the octet rule, one atom that does not want to have 8 electrons. Who is it? Tell your partner. Who is an atom that does not want to fill up to 8 electrons? Hydrogen. Hydrogen only wants 2. Now there's a couple other, there's 3 other atoms that have what we call incomplete octets because it's not a full 8. It's going to be less than 8. And those ones are beryllium, Be, boron, and aluminum. Beryllium only wants to have 4 electrons. Beryllium and aluminum want to have only 6 electrons. There are also expanded octets, but that is going to be an enriched topic So you do not need to know about expanded octets unless you should choose to study that additional portion. Okay, if you do choose to study that, they are in periods 3 and lower. Could you guys all please look on your periodic table or on one of the periodic table and tell me who is the first element in period 3? First element in period 3 is sodium. So if you go all the way across, who is the last element in period 3? That would be argon. So you have to be like argon, like in that row or below, in order to have expanded octets, which you don't need to know about unless you want to. Yes? Okay. So, what do you remember about how hydrogen bonds? How many bonds can hydrogen form? One. Hydrogen can only form one bond. So hydrogen, as well as the halogens, could you please tell your partner the names of all the halogens? Feel free to refer to your periodic table. So who are the halogens? Fluorine, chlorine, bromine, iodine. We're not going to worry about astatine because it's radioactive and we'll never use it, okay? So just fluorine, chlorine, bromine, iodine, and then the ones below that don't really matter. So hydrogen and the halogens all have only one bond, okay? Never, don't put more than 4 bonds around the central atom unless you're doing the enriched stuff. Try to make that look like a diamond in period 3 or lower. Okay, so not more than 4 bonds ever for most of you. Okay, never more than 4 bonds. How many electrons are in one bond? 2 electrons. Okay, so if we have one bond, a bond has 2 electrons, and they're shared by each atom. So here are the rules that we are going to follow, and we're just going to work through this first one. Okay, we're actually going to work through a couple of examples together, and then look at it, and then we're going to try a couple on our own. So the first thing you need to do you remember last day when we were looking at our structures, we had to say, how many valence electrons do I have from the atoms I have given? Do you remember doing that? You know, we had a carbon and we had an oxygen. We had an oxygen. Carbon has 4 valence electrons. Oxygen had 6. And oxygen had 6. So that would give us a total of how many valence electrons? 16. Yes? So when we finished drawing our structure, we needed to have the same number of valence electrons at the end. Yes? So you count up how many valence electrons you have. You need to have the same amount once you finish drawing your structure as you figured out you have at the beginning. Okay, so here's carbon. Here's oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, now, for example, here we have CH3I. Carbon has 4 electrons. How many valence electrons does hydrogen have? 1. But we have 3 hydrogens, so we multiply that by 3. And then iodine is in group 17. How many valence electrons? 7. Okay, because iodine is group 17. So if we take that and we add that up, we have 4 plus 3 plus 7, and we get 14 electrons. That's the number we need in our final structure. Now, part of the tricky bit is to arrange the atoms. So this figures that you have to figure out where they all go in relation to one another, and we form what we call a skeleton structure. Now, remind me about carbon. How many bonds does carbon form? 4 bonds. So if you have carbon present, guess where it's going to be? It's going to be in the middle because it's going to bond to 1, 2, 3, 4 things. Okay, so if carbon is present, it will be the central atom. Otherwise, now this is a word you probably don't know, the least electronegative is central, which means the furthest to the left and the furthest down on the periodic table. Now, for the most part, you're going to be able to tell because you'll be like, oh, I have 1 nitrogen and I have 3 chlorines. The 1 nitrogen is going to go in the middle. Yeah. Could you ever put hydrogen in the middle? Hydrogen can't go in the middle because it only has 1 bond. How about fluorine? Can fluorine go in the middle? No, because fluorine can only form 1 bond. How about chlorine? No, chlorine can only form 1 bond. Okay, so for the most part, it's going to be pretty obvious. Also, we will tend to write the formula sort of in order. So if there's 3 elements in a row, we'll probably put them in that order. Okay. So let's take a look at this. We've taken carbon. We had our element was CH3I. And we're going to put the C in the middle. And then what we do is to draw this skeleton structure, we draw bonds to each of the outside atoms. Draw a single bond to each of the outside atoms. Now let's remind ourselves, how many valence electrons do we have to work with? We have 14 valence electrons to work with. How many valence electrons have we used so far? 8. We have used 2, 4, 6, 8, because each bond is 2 electrons. So we've used 4 times 2 is 8 electrons. How many electrons do we have left? 14 minus 8, we have 6 electrons left. Okay, so what we're going to do next is we're going to say we need to make sure that everybody has a complete octet except for elements that don't want to have 8. Yes? So, who is satisfied at this point? Is our hydrogen satisfied? Does it have as many electrons as it needs? Yes, because hydrogen only needs 2. And guess what we have here? We have 2 electrons in that bond. Yes? How about this hydrogen? Is that hydrogen good? It's got a bond attached to it. That's 2 electrons. Hydrogen needs 2. So that hydrogen is good. Why does hydrogen need 2? Because when we look at a Bohr model, hydrogen only has electrons in the first shell, and the first shell is full with 2 electrons. We're always trying to fill up the shell. All the rest of them need to have 8 electrons to fill their shell. So anything after hydrogen will have, like, it'll be the second shell that's filling up or the third shell, and those ones fill up with 8 electrons. Did that make sense? Okay. So hydrogen's good with 2, so all of our hydrogens are just fine. How about carbon? Tell your partner, is carbon satisfied? Does it have a complete octet? Well, we have 2 electrons, we have 2 electrons, we have 2 electrons, and we have 2 electrons. Does that make 8? Yes. So carbon is also satisfied. Now we have to say iodine. Is iodine satisfied? Iodine is not hydrogen, so how many electrons should it have? It should have 8. How many does it have right now? 2. So we're just going to put lone pairs on there until it has 8. 1, 2, 3, 4, 5, 6. So now we add lone pairs. So first you draw the skeleton structure, and then you add lone pairs until everybody has 8 except for hydrogen that only needs 2. Okay? And then once we are done that, we have to check and see, do we indeed total up to 14? So if we count our bonds, we have 2 electrons in each bond. So 2, 4, 6, 8. And then the lone pairs, 2, 4, 6, 8, 10, 12, 14. Oh, guess what? You guys are not nearly as excited about this as I am. It's really exciting. We wanted to use 14 electrons, and how many have we used? 14. So we are done with this structure, and we don't need to do anything more. Okay? And you might think to yourself, you might think, I could do this molecule. This molecule looks pretty easy. I could probably do that the way we did it yesterday. And yes, you probably could. But maybe you'll get a molecule that needs a double bond, and you won't know that it needs a double bond, and you'll try cramming them together, and it will become frustrating. So this method of doing it will always get you to the correct structure with as little frustration as possible. You with me so far? Okay, cool. Okay, so it shows you here, step 3 is basically you add those lone pairs. Those are the ones there that we did that on the previous page. And then I like to call this the count and check. Count and check. And that's where we count up and say, do we have 14 electrons? 2, 4, 6, 8, 10, 12, 14. Yes, we do. Okay. So that's it. Example 1 is done. Now, if and only if we had too many electrons were used. Let's say my structure had 16 electrons instead of 14. We are going to erase one or more lone pairs from the central atom, and we'll come to an example like that a little bit later on. Now, I think I actually have a set of these rules. There is a set in the front of your book, but I want you to have a set you can refer to without having to flip to the front of the book. So I'm going to grab that now. Okay. So you guys can actually turn right now to page 5. Okay. But I'm going to give you this extra handy dandy handout as well, which will give you page 5.
Good.
Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5.
Wait, I have this.
1, 2.
Oh,
It's okay. It's okay. 3, 4. This is just here so you don't have to keep flipping back to page 5. It's like having a periodic table out for reference.
Yeah, for sure.
Okay. 1, 2, 3, 4. And 1, 2.
Oh, Miss Fast, can I use the watch this?
You sure can. Okay. So, what does it say? It gives you the steps, and the reason I've given it to you as a separate page is so that you can have it out in front of you and you don't have to keep flipping back to page 5. Yes? But if you lose this, this is on page 5, right? So it's kind of nice to have it there. So you are going to be counting your valence electrons, step 1. Step 2, you draw the skeleton structure. Who goes in the middle? Usually carbon, or the least electronegative. Now let's just talk about that. If we had to, let's get rid of all of this nonsense here. Fluorine is the most electronegative. I'm just going to call it electroneg because I'm running out of room. So everything further down and to the left is less electronegative. Okay, so if you had a choice as to put oxygen or phosphorus in the middle, who would you put in the middle? You would put phosphorus in the middle because it is less electronegative than oxygen. Does that make sense? Now, sometimes this rule is not going to help you, and in that case, I might even just tell you what the central atom is, which might make your life easier. I'll be like, oh, selenium is the central atom. Okay? So don't get too worked up about it. Don't get freaked out that, oh, I won't be able to tell. No, yes, you will. You'll be good. Okay? All right, so we draw our skeleton structures. And then we check to see if everybody has 8 electrons. But we add lone pairs so that everybody has an octet. How many is an octet? 8 electrons. Who doesn't want 8? Hydrogen. The other ones are beryllium, boron, and aluminum. Now, hydrogen wants to have a maximum 2 electrons, yes? We're good with that one? You're just going to have to believe me on this because the explanation goes a little bit into depth, but beryllium wants to have 4. And boron and aluminum want to have 6. So it just goes 2, 4, 6. Okay? Now, how on earth are you going to remember these? Hopefully hydrogen has become part of your brain now, right? Or it is in the process of becoming part of your brain. But how are you going to remember beryllium, boron, and aluminum? Let's think about basketball. Sometimes we call basketball B-ball. Yes? Okay, look what we have. B-ball. B-ball. Okay, so basketball tells you which atoms do not need the full 8. They want to have 4, and then the ball wants to have 6. Does that make sense? Sort of. It might help you remember. Another thing that might help you remember is if you take a quick look on page 7, here we have B, and here we have ball. Yes? And here we have hydrogen. So hydrogen needs 2, beryllium needs 4, and boron and aluminum need 6. Okay? If you forget, and if you're like, I'm going to forget on the test, for the cost of 1/2 mark, I can sell you those values. I can be like, hydrogen needs 2, beryllium needs 4, aluminum and boron need 6. Okay, so that would cost you 1/2 mark on a quiz. So your choice, either memorize them or pay 1/2 mark to get that. I'll just give you like, I'll have like a little piece of paper that says that on it, okay, and you can get that. All right, back to this one here. Now, all we did this time was we counted and checked, and we see, do we have the same number of electrons as we counted up in step 1? If we have the same, then we get to skip steps 5 and 6, and we go straight to step 7. And if it's an ion, guess what we need to do? We need to put brackets and a charge. And then resonance structures may or may not be enriched. We'll see where we get to, okay? All right, so we'll worry about that later. Steps 5 and 6 deal with multiple bonds. It's like you need 16 electrons, but you only have 14. Oh, what do we do? We'll figure that out in just a little bit. Okay? So you can refer to this at any time. There's some pro tips. Never, ever double bond an H or an F. Never have unpaired electrons. So you never, ever want to see that in your final structure. Okay? You should never have hydrogen double bonded. You should never, ever have fluorine double bonded. You should never have hydrogen with 2 bonds like that, or fluorine with 2 bonds. Okay, none of those. No, 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 no. No. Okay? Don't worry about the sigma and pi stuff. If you want an expanded version of the rules with more detail, it's on the back. Okay, so if you feel like you want it, you can refer to the back of that page. Okay, let's go try a couple more. So back here, there we go. Okay, we're going to try. This example is given on page 107. But I'm going to do it from scratch over here so you can see the steps as they come up, okay? So step 1. Anyone remember what step 1 is? Or is willing to read it off the sheet of paper? Count the valence electrons. Oh, I haven't written a compound yet. That's going to be hard to count them. I guess I should write what you're going to draw first. Count the valence electrons. So we're going to do IBR. Okay. Please tell your partner how many valence electrons in I. I. Iodine is in group 17. Therefore, it has 7 valence electrons. Bromine is also in group 17. Therefore, it has 7 valence electrons. Okay. So we have 7 electrons and 7 electrons. So that is 14 electrons. Skeleton structure. We have an I, and we have to attach it to a BR. There's no other way to attach these things, yes? Is there any other way to attach these things? No worries. There you go.
Thank you so much.
Is there any other way to attach 2 atoms other than just to put a stick between them? No. There's no other way. You just have to put a stick between them, okay? So, how many electrons does iodine need? So this was our skeleton structure. Number 2, we draw our skeleton structure. Step 3, we add lone pairs until everyone has 8. Except who? Hydrogen and BE, B, and AL. Okay. Do we have any BE, B, and AL or hydrogen? No. So everybody needs 8 electrons. How many electrons does iodine have right now? Remember, a bond is how many electrons? 2 electrons. So how many electrons does iodine have? Oh my God, you guys are killing me. How many electrons does iodine have? How many does it have right now?
2.
It has 2 because it's got a bond. It wants to have 8. So we are going to add lone pairs, and we can add one to the top. We can add one to the bottom, and we can add one to the side. And now how many electrons does iodine have? 8. Okay. Bromine. How many electrons does it have? 2. How many does it need? 8. So what should we add? Lone pairs. How many? 1, 2, 3 lone pairs. Step 4. Count the electrons in the structure. So everybody count the electrons in the structure. See how many you get in this structure. Count up the electrons. Do it now. Once you've made a total, tell your partner. 2, 4, 6, a bond makes 8, 10, 12, 14. So you count and then you check against step 1. Do we have the same number? We're done, unless it's an ion. Is it an ion? No, we're done. Is good? So simple molecules will be very, guess what? Simple. You're not going to be very challenged by them, I hope. Okay? You'll follow those rules and you'll be like, okay, that's pretty good. All right. Do we feel like we need to do another example or are we okay?
We're good.
We're good. We can move on. Excellent. So now we're going to do, and this example is on page 108. BH3. BH3. Step 1, count the valence electrons. How many valence electrons in boron? 3. It's in group 13. How many valence electrons in hydrogen? 1. But we need to multiply that by 3 because we have a 3 there. So now we're going to add that. So 3 plus 3 is 6. Okay, so we have 6 electrons. So we've counted our electrons. Step 2, draw a skeleton structure. Who do you think goes in the middle? Can hydrogen ever go in the middle? No, so let's put boron in the middle. There's boron. And how will you attach the hydrogens? What will you draw to attach them? You will draw a line. So we're going to go 1, 2, 3. Would it be okay to draw it like this? Would that be okay?
Yes.
Totally fine. Doesn't matter. You take your pick. Yes? All right. Now, you have to make notice here. There's something that in your head should be going bing, 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 bing. Bing starts with a B. And guess what we have? We have B. Yes? And how many electrons does B need to have? It needs 6 electrons, not 8. So we don't want to add a lone pair. Okay? Do not add a lone pair because how many electrons does boron have right now? 2, 4, 6. 6 electrons. Check. Hydrogen has 2 electrons. Check. Hydrogen, each hydrogen has a bond, so it has 2 electrons. And this one has 2 electrons. Check. Is good? Okay, so you just have to watch out. And if you see a B or an Al or a hydrogen, just make sure you're not trying to put too many electrons on there. And guess what our structure has? It has 2, 4, 6 electrons, which is the same as we wanted at the start. Is good? Okay, we're going to move on then to things with some double bonds, I think. Or are we going to do, oh, yeah, multiple central atoms and multiple bonds. Here we go. Let us start with, and this is on page 111. And we're going to start with CH2O. Tell your partner what step number 1 is.
Count.
Count. What are you counting? Valence electrons. How many valence electrons in carbon? 4. How many in hydrogen? 1. Do we have to multiply it? Yes. Times 2. And how about oxygen? 6. And now we're going to add 4 plus 2 plus 6 is equal to 12. So we counted our electrons, valence electrons. Step number 2, what do we do? Skeleton structure. Who's going to go in the middle? Carbon. And then you just put the other atoms around it on the outside. Okay, you just put them like on various sides. So you say, I'm going to put hydrogen over here. I'm going to put a hydrogen here. And I'm going to put an oxygen here. And I'm going to attach them each with one bond. Now you're going to give everyone 8 electrons by using lone pairs, other than hydrogen and B-ball. So if we look at hydrogen, does hydrogen need any lone pairs? No. Other hydrogen obviously does not need lone pairs. Does carbon need any lone pairs?
Yes.
It has 2, 4, 6 electrons from the 3 bonds. So how many lone pairs does it need? 1. Okay. Oxygen. Oxygen has 2 lone pairs from that bond. Okay. So how many lone pairs does it need? 3 lone pairs. So we're going to put one on the top, one on the side, and one on the bottom. We're always going to try and have things on the top and the bottom and the 2 sides. Try not to put things weird diagonally shapes. It just makes your life yucky, okay? Now, step number 4, what do? We count and check. So please count up the number of electrons in this structure and tell your partner what you get. 2, 4, 6, 8, 10, 12, 14. Oh no, that is not the same. So here's the deal. If we have 1 pair too many, yes? So this is where we go to step 5. And step 5 is to erase a lone pair from the central atom. The number of lone pairs that you erase will be the number of multiple bonds formed. So how many multiple bonds are we going to have? Well, we have 1 pair too many, yes? So we're going to erase 1 lone pair. So how many multiple bonds will we have?
1.
Just 1. This is kind of a nice way of like doing accounting with our atoms so that we keep track and we end up with the right number of bonds at the end. So let's take this structure And I am going to redraw it down here. H, H, O. But I'm going to take off this pair. We're going to erase it. So it's now gone. Yes, you can see it's gone. Okay. So that's part 1 of step 5. So that's like 5A. 5B, you're going to turn lone pairs into bonding pairs. So what we're going to do is we're going to say, look, let's look at carbon right now. How many electrons does carbon have? How many electrons does carbon have? 6. How many would it like? 8. You know what oxygen is going to say? I am just so nice. I will share another pair with you, carbon, so that you as also can have 8 electrons. Yes? Because I get to keep them because I'm still bonding with me, and like oxygen still has 8. So what's going to happen is this is going to turn into a bond. Okay, so that red one is now a double bond. That's our multiple bond. And the rest of the structure stays the same. And now we're going to count and check again. Count how many electrons are in this structure. Tell your partner, how many electrons in this structure? 12. 2, 4, 6, 8, 10, 12. How many did we want? 12. Yay! And now you're also going to double check and make sure everybody has 8 electrons. Does everybody have 8 electrons? Yes. So at the end, it is really important that you check the number of electrons in total that you have, and that you check that everybody who needs 8 has 8. Because it's so easy to make a stupid mistake and then be like, oh, I've just made this horrible mistake here. All right. We're going to try another one. Oh, that looks complicated, doesn't it? Yes? Now, for one like this, I might actually give you a skeleton structure, but I'd like you to see if you could try, let's count our electrons first, because that's always step 1. We have 4, we have 3 times 1, we have, how many electrons does nitrogen have? 5, and we have 2 times nitrogen, which is, or hydrogen, which is 1. So we have 4 plus 3 is 7 plus 5 is 12 plus 2 is 14. Who should go in the middle? Carbon. How many hydrogens do you think are attached to carbon? 3. Who else maybe could also go in the middle-ish? N. So we're going to put N here. And then what are we going to attach to N? Hydrogen and hydrogen. So don't get freaked out by the fact that you've got this big sort of looking molecule. Just be logical about where you put things. Hydrogen always has to go on the outside. And if you get stuck, you can always ask me. Okay? All right. So that's step number 1 is count. Step number 2, skeleton. What's step number 3? Lone pairs. Who needs lone pairs here? Nitrogen, because carbon has 2, 4, 6, 8. Nitrogen only has 2, 4, 6, so we need to put 8 there. Step 4, you're going to count and check. Two, 4, 6, 8, 10, 12, 14. And you're done. Pretty easy, yes? Okay. Let's see if I have one more double bondy kind of one here. Yeah, okay. C2H2. Count. How many valence electrons in carbon? 4. Do I need to multiply it? Yes. And then how many electrons in hydrogen? 1. And do we need to multiply it? Yes. So now we have 8 plus 2 is 10 valence electrons. I would like you to see if you could try making a skeleton structure out of this thing. And remember, if you have a choice as to whether to be symmetrical or asymmetrical, always choose symmetrical. Symmetrical is happy. Check to see if your skeleton structure looks like mine, or at least something close. Does your skeleton structure look like mine? Carbon's in the middle. You could, in theory, put 2 hydrogens on one carbon and none on the other, but like I said, what did I say? Symmetrical is best. So if you can put 1 on either end, that's best. Number 3, you're going to add what? Lone pairs. Who needs lone pairs? Carbon, we need 2 here and 2 here. Step number 4, count and check. All right. 2, 4, 6, 8, 10, 12, 14. Uh-oh. 14 electrons. How many pairs too many? 2 pairs too many. So how many pairs will we need to erase? Okay, so step 5, erase 2 lone pairs from the central atom. I'm going to put Z. So I'm just going to erase the ones that are on the top here, and I'm going to erase 1 from each just because it's more symmetrical. Okay. So now I have H, C, C, H, do-do-do-do, do-do-do-do. So that's 5A, is to erase those pairs. But remember, when we start erasing pairs, that also tells us how many multiple bonds we're going to have. How many multiple bonds will we have if we erase 2 pairs? We will have 2 multiple bonds, and they can be in the same location or different locations. It doesn't matter. Okay? Right now, how many electrons do each carbon have? 6. But what if the carbon on the left was really generous and said, oh, I will share with you, my friend? Yes? And we will take that lone pair and change it into a bonding pair. Okay, so 5B, turn lone pairs into bonding pairs. Okay, so now we're going to redraw that. We've got H, C, and that's the pair that came from that lone pair there. C, H. Now, two things. We said we needed 2 multiple bonds. How many multiple bonds do we have right now? Just the one, the red one. Yes? Also, is everybody satisfied? Does everyone have 8? No, this carbon only has 6 electrons. How could we fix that? We could take another lone pair and turn it into a multiple bond. Okay, and you can do this all at once. You don't have to do it in 2 steps, but I wanted to show you how it works. Okay, so now we have H bond, C, and we have bond, and then we have that red bond and the blue bond, and now we have carbon and hydrogen. And now finally we count how many electrons in total? 2, 4, 6, 8, 10. Oh my gosh. Those of you who are on your phones, I'm so sorry that you won't do well on this quiz. It grieves me, but there's nothing I can do about it. Okay? Because I'm not the one on my phone. And I'm up here being as animated as I possibly can be, which is like crazy. Anyway, okay. We have 10 electrons. Does everyone have 8 electrons that needs it? Yeah, because everybody's got 4 bonds except for hydrogen, which only needs the 1 bond. So what are you guys going to do? We are going to assign you not some from this one and some from the last one. You're welcome to look through the other examples. Okay, there's a ton of examples here. Fluorine never forms double bonds. So you're going to do on page 117. You're going to do numbers 1 through 4 and 13 through 16. That was exciting sounding. And you're also going to do on, let me just see, I'll come back to this page in just a second. I just need to find this page number here. Numbers 1, 2, 3, and 7, 8, 9. And that's on page 110. And if you're like, wow, that's way too many, then just take 1 off of each of those sets. Do you know what I mean? Like if you're like, I have so much homework tonight, I cannot finish all of those, then maybe do numbers 1 through 3, and then 13, 14, 15, and then 1 and 2, and 7 and 8. Does that make sense? Okay, so make this manageable for yourself. If you're really pressed for time tonight, do at least 1 from each of those groups, right? So make it so that you can complete at least some of each of those. Yes. Yes. Yeah, because we said, oh, then.
Yeah. And the reason that sometimes when they'll just need you to put on your laptop. But the reason I have them do that is oh, I'm great. So the 2 pairs of laptop. It just makes the accounting a little bit. Yeah. That makes sense. They're sort of there just to help us put it on what we don't. Yeah.
Thank you guys, that was a long lesson, but I hope it was understandable.
Oh, okay, so many things.
Yeah, and you draw a line and looking that way.
Oh.
Yeah, so you go on there. Yeah. And now you put your own person on there. Oh, are there this oxygen?
Yeah.
Is oxygen happening?
It is, yeah.
Oh.
No.
So we got 2, 4, 6. How many does it take?
Oh. You wanna know?
So a lot of them use for a half, but
Yeah, we can put that in the- Oh, okay.
Yes.
Thank you.
So you need to go on and make sure
Yeah.
everything
I know, like, these all have.
yeah, those all have aids, then you
Yeah, to go to the off.
exactly. Because what you gotta do, you gotta create skeleton structure there, but you have a long pushing.
Yeah.
Yeah. Remember what all means. Bean. 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 Bean is special. How many is bean mean? 6. Do you have one that would be yeah, yeah. Yeah. That's gonna be going on, it's a little bit. Yeah, yeah, and it actually won't be that bad, just, you know, do it a little bit. And that'll be a line. So how are you going to go? A lot more. Yeah. Yeah. Yesterday, I just haven't put it down yet. We're done, that's okay, we're good, we're good. Yes. Yes, so sometimes you'll find that like yesterday's not gonna be work, and you can just be like, okay, I'll just count them together, get the orders, check from the end and say, do I have the same number of electrons?
I think he doesn't match the question.
Don't try either of those things.
What the?
Yeah. I've actually tried starting this, like, understand. So that's why.
Even what you want,
Is that when you-
I think that's possible.
People are like, they just.
Or
Like, time, that whole thing that happens, so like. So I.
Is it even possible to do a quadruple bond when like
No,
function was the max?
no quadruple bonds.
The last thing you locked in, I just put like 4 together.
Yeah. Thank you.
Also like after like this page,
Uh-huh.
it doesn't match up with
Oh, it doesn't match?
yeah. Take a look.
No.
It's
Uh-huh.
like at 2, but it's 2.
I need to fix that. Okay. Yes. Carbon wants to have 4 bonds, and oxygen likes to have. Good. I wasn't able to be here this morning anyway because I had a meeting.
Oh.
Yeah.
I thought you just like.
Yeah, no, I had a meeting. Yes. Yes, it's all good. Don't worry. And I found your test. It was in that pile that I looked through. And I must have gone past it. And I'm like,
That's okay.
anyway. Okay, tomorrow?
Yes.
Okay, cool. Okay.
Great.
Thank you for checking in, Christy.